Now let us talk about the different components of an embedded system. In the architectural view, we have seen we got a preliminary idea about different ingredients in an embedded system. So here we will see some elaborated version of that. Inside an embedded system, we do find microprocessor or microcontrollers. This is the heart of any real-time embedded systems. Microprocessors used here are different from general purpose processors like Pentium, Sun, Spark, etc. They are designed to meet some specific requirements. So mostly microcontrollers are being used as popular choice for the CPU of the embedded system. Like Intel 8048 is a special purpose microprocessor which is used in keyboard of your desktop computers. Mobile phones, digital camera use special purpose processors for voice and image processing. A washing machine may use some other type of processor for real-time control. Then next we have got memory. So microprocessor and memory must coexist on the same printed circuit board or on the same chip so that their performance can be improved. And the when distance between the microcontroller and the uh, memory chip is less, so data access speed will be better. In case of memory, compactness, speed and low power consumption are the characteristics required for memory to be used in an RTES. For housing the operating system, we need read-only memory. Flash type of memory also used as program or data loaded, and that might need to store uh, within it for a considerable period of time. For example, we may like to change the ringtone or display color of the mobile and keep it for some time till the next change is made. So for that some temporary storage is required, but that should not be erased when the power is off. Next we have input output devices and their interfaces. Input output interfaces are necessary to make the real-time embedded system to interact with the external world. So they are told as ears and eyes of the embedded system, without which uh, the embedded system cannot interact with the external world. And some examples of I/O devices are like visual display unit such as TFT screen or LED screen in mobile, then touchpad which is an input device, antenna which is used for transmitting the signal from the mobile phone or the embedded system, and vice versa. Microphone which is an input device used to record the voice. Speakers we use for playing the uh, voices, which works as an output device, so on and so forth. These RTES should also have interface to other devices such as desktop computers, local area network and other RTES. For example, songs from an internet site may be downloaded into an MP3 player. These I/O devices along with standard software protocol in the RTOS provide the necessary interface to these standards. In the component we have after hardware we have software. So the RTES is the just physical body as long as it is not programmed. So it's like a human body without life. The real time operating system takes care of various activities in an RTOS. In case of a mobile phone, the RTOS checks and make indication about the signal condition, battery power, status, etc. Then an RTOS is valued more for how quickly and or predictably it can respond to a particular event than for the amount of work it performs over a given period of time. Examples of RTOS are QNX, this is Unix like, then FreeRTOS, then JFIR, VxWorks, etc. So these are being developed by different developers and are available for implementation in various type of systems. Now a page where we will see the comparison between general purpose computers and embedded systems. As we can see, left side is our general purpose computer, right side is our embedded system. So general purpose computers will be having microprocessor, cache memory, primary memory, input output interfaces, then keyboard, hard drive, network card, video display units, etc. And all of them are supplied with power. In embedded system, we can see things, the blocks are much optimized, so only the required amount of resources are only kept, where obviously there will be a central processing unit which can be a microcontroller, there will be primary memory, there may be secondary memory, but the amount will be restricted based on the requirements, and input output devices such as AD converters, user, then infrared ports, etc. are there, and all of these obviously needs power supply. If we compare point wise, then we can have this sort of picture between embedded system and a general purpose computer system. Like specialized, if we talk about definition, an embedded system is specialized computing system designed for specific tasks, and on the contrary, the general purpose computing system is multi-purpose system designed to handle a variety of applications, because it can be the general purpose computers can be used in any application, so that's why they are kept general during its manufacture. The purpose of embedded system is dedicated function and a very specific task, whereas general purpose can handle a wide range of application and operations. If we talk about hardware, in case of embedded system, they are optimized and minimal hardware tailored for specific application. But on the contrary, general purpose hardwares with high processing power and flexibility is required for general purpose computing system. In case of software for embedded system, it is run specific, often real-time software. But general purpose computers can run complex operating systems such as Windows, Linux, Mac OS, etc. Examples: microcontrollers in washing machine, IoT devices, ATMs, etc. Are the example being used of embedded system. And in case of general purpose computer system, personal laptop, tablets, personal computers, etc. are the examples of general purpose. Then if we talk about performance, so embedded systems are designed for efficiency and reliability in specific tasks, whereas general purpose is designed for versatility and high computational power. Scalability is very limited, so system upgradation is limited scope in case of embedded systems. and hardware and softwares are very tightly coupled. Whereas in case of general purpose computers, highly scalable, they can be upgraded in hardware, they can be upgraded in software also. Embedded systems frequently operates on real-time basis, so it performs real-time operation, but general purpose computers hardly work on real-time requirements. Cost is low in case of uh, embedded systems as they are very optimized and application oriented. General purpose is having high cost due to advanced hardware and flexibility. Power consumption in case of embedded system is lower because they are optimized for energy efficiency, and in case of general purpose computer, obviously compared to embedded system, their power consumption will be higher. In case of user interface, embedded system has minimal or no user interface, controlled automatically or via sensors, and general purpose computing systems has to keep provision for many type of user interfaces like keyboard, touch screen, HDMI port, then VGA port, so on and so forth. Examples of embedded system: automotive systems, medical devices, industrial machine, etc. In case of general purpose, they are used for browsing, gaming, content creation, software development, etc.